In the previous video, we verified at least one of the laws for the law of cosines. Let's just assume that they all work. Okay, so in this video, we're going to start implementing and using the law of cosines. So let's say for some reason we were asked to find all the missing angles from this given triangle. All right, one thing we could do right away is we could use the formula, okay, and we could just go back up here and remember that cos A, cos B, and cos C are equal to some sort of relationship between the sides. Okay, so we could say that the cosine of A is going to be equal to B squared plus C squared minus A squared divided by 2AB. Okay, so I just copied a formula from up top. Or another way to think of this is that A is going to be the inverse cos of B squared plus C squared minus A squared divided by 2AB. And so now we could just go ahead and fill in that A is the inverse cos of B squared, which is 7, C squared, which is 7, and then A squared, which is going to be 25, or 5 squared. I'll just go ahead and put it in there as 5 squared since I put the other ones in there as 7 squared, minus 2 times 7 times 7, right? If we compute this, A is going to be equal to the inverse cos. This is going to be 49 plus 49 is 98. 98 minus 25, 73. The denominator, 2 times 7, 14. 14 times 7, 98. Okay. And of course, if we don't believe it, we can just go in our calculators. 2 times 7 times 7 is 98. And then 7 square plus 7 square minus 5 square. There we go. We're going to find the inverse sine of that. Okay, so we're going to find inverse cosine, excuse me, of 73 divided by 98, and that gives us 41.8. Okay, so that means that A is about 41.8 degrees. Now, at this point, let's see if we can figure out another one of the sides, or the angles. At this time, we could just use the law of cosines, because we know that A is 5 for the side, and A is 41.8. So this means that we're going to have the sine of 41.8 degrees divided by 5, which is the side. And it really doesn't matter because B and C are the same. So let's have 7 over sine of B. Now we can multiply both sides by 7. We have 7 sine 41.8 degrees divided by 5 equals sine of B. Right? Then I can find the inverse sine. Okay, so sine minus 1 of 7 sine 41.8 degrees divided by 5 is equal to B. And then now we can just go ahead and compute that. Okay, so with our calculators, we're going to go ahead and we're going to find the inverse sine of, we had 7 sine 41.8. So 7 and then sine and 41.8. Close parenthesis, divided by 5. All right, we get 68.9 approximately. Finally, to get the last one, we could just go ahead and subtract both of those angles from 180. Okay, so C, which is the only angle left, is going to be 180 minus whatever A was, 41.8 degrees, minus whatever B was, 68.9 degrees. And so C, if we compute that, we're going to have 180 minus 41.8 minus 68.9, I believe. Let me just check those numbers really quickly. 41.8, 68.9. We get 69.3. All right. So those are going to be our 3 angles, okay? Now be careful because these are approximations, okay? These 2 angles should technically be the same, but we had some round off there, okay? So just be careful of that. A second example, we have B is equal to, or sorry, A is equal to 10 feet, B is equal to 3 feet, and C is 15 degrees. So we might have a triangle that looks something like this, okay, where we have 15 degrees is really small. Let's call this A, which is going to be 10 feet, all right? And let's call the other side 3, all right, which is going to be B. And I know this is not the scale. All right, so B is 3, so this would make this B and C, and this is side C. All right, Now, we might remember that we had this formula. The cos of c is going to be equal to a squared plus b squared minus c squared divided by 2ab. All right, that's our law of cosines. And the reason I'm using this one is because we know one of the angles, we know angle C, so we should really start with that, okay, because there's only one angle that we can use at a time with the law of cosines. So now we get the cosine of 15 degrees is going to be equal to 10 square plus 3 square minus c square divided by 2 times 10 times 3. Okay, so just by substituting, we know that this is going to be 60. Right? So I can multiply both sides by 60 to clear that out. So 60 cos of 15 degrees is going to be equal to 10 square plus 3 square minus c square. And then what I can do is to solve for c square, I can go ahead and subtract 10, subtract 3, 10 square, 3 square, and then divide by -1, and then take a square root of that. Okay, so a little bit of algebra to do, but we're pretty close to the end of this. So I get that 60 cos 15 degrees minus 10 square minus 3 square equals negative c square. Let's compute this really quickly and see what that works out to be. Okay, so in our calculator, we have 60 cos of 15 degrees. And then we have minus 10 squared minus 3 squared, right? And that's negative 51.04. Okay, so we get negative 51.04 equals negative c square. If we multiply both sides by -1, 51.04 equals c square. And now I can take the square root of both sides. So square root of 51 is just going to be a little bit bigger than 7. Right? So if I clear this or hit enter, I have the square root of 51.04445042, and that's 7.14. Let's just say 7.1 is C. So C is 7.1. Okay. All right. And it's in feet. So we have that. All right. So now we have all three sides, okay, which is good. We need a couple more angles. So we can use the law of sines to be able to find another one of the angles. Let's try to find angle A. Okay. So we know that the sine of A divided by side A, which is 10. And we certainly know angle C and side C. Okay, so let's just say we know that angle C is 15 degrees. So sine of 15 degrees divided by 7.1. And then we could multiply both sides by 10 and then take, so we would have the sine of A equals 10 sine of 15 divided by 7.1. We could take the inverse sine to find A. So that's going to be 10 sine of 15 degrees divided by 7.1. All right. And then that can get us to our answer. All right. So in our calculators, we have 10 sine of 15 divided by 7.1. And we have an inverse sine of that. All right. And so we get 21.4 to be A. Okay. And that's going to be in feet. Or sorry, that's going to be our angle. So 21.4 degrees. Right. And then finally, to get B, which is the only angle left, we're going to have 180 minus 21.4 degrees, which was A, and then minus 15 degrees. Okay. And that means that B is going to be, punch that in, pull this out. So we're at 180, pull all of it out. So 180 minus 7.1, or sorry, 21.4. And then minus 15. So we get 143.6 for the last. So that's going to be 141 point. Sorry. 141.4. or 143.6. Okay. And so that's going to be all the components of the triangle by using our law of cosines in tandem with our law of sines. Okay? All right. So a thought might be is that when you're going to solve these sorts of problems, okay, start with your law of cosines, okay, and then see what's missing and see what you have, okay, and then try to manipulate the formulas so that way at least you can fill in the blanks. You might have to do some algebra, but at least you'll be able to solve this. Okay, so in the next video, we're going to take a look and see how we can go through and find a few more of these types of triangles and complete those.